62 amp 15 kilowatt generator can be used with a 200 amp automatic transfer switch powering a 200 amp panel with a 150 amp load, provided certain conditions are met. Firstly, generator capacity is important. The generator must be able to supply sufficient amperage and power to meet the load requirements. In this specific situation, the generator's 62 amps of 15 kilowatts exceeds the 150 amp load, which suggests it is capable of handling the load. Secondly, automatic transfer switch or ATS compatibility matters. The ATS must be rated for the generator's amperage and voltage. Given that the ATS is rated for 200 amps, it can easily handle the generator's 62 amp output without being overloaded. Thirdly, panel capacity needs to be considered. The panel's capacity, in this case 200 amps, must be equal to or greater than the generator's output and the load requirements. As the panel is rated for 200 amps and the generator is supplying a load that requires less than this, the 200 amp panel meets this condition. Fourthly, the circuit breakers in the panel are significant. The circuit breakers should be sized appropriately to protect the wiring and devices on the load side. If the generator is supplying a 150 amp load, the circuit breakers should be rated for at least 150 amps to ensure they can handle the current safely without tripping unnecessarily and to protect the circuit. Fifthly, effective load management is crucial. It's important to manage the load connected to the generator to avoid overloading it. The total load on the generator should not exceed its rated capacity. If necessary, non-essential loads can be disconnected during generator operation to reduce the demand on the generator. For instance, turning off lights, air conditioning units, or other high power consuming devices when the generator is running will help prevent an overload. It is always important to prioritize safety first. Always adhere to the manufacturer's instructions and local electrical codes when using a generator and ATS. Proper installation is essential. The generator ATS and panel should be installed by a qualified electrician to ensure proper operation and safety. A professional electrician can verify that all components are correctly wired and grounded, and that the system meets all applicable safety standards. Generator overload is a risk. If the generator is overloaded, it can damage the generator or the connected equipment, or both. Monitor the load carefully and avoid exceeding the generator's rated capacity. Using a clamp meter to measure the current being drawn can help prevent overloads. Also, ensure the generator has an adequate supply of fuel to meet the load requirements. Running out of fuel during operation can cause the generator to shut down unexpectedly, which can be problematic if it is providing backup power during an outage. Remember that the generator provides 62 amps at a specific voltage, such as 120 volts or 240 volts. The wattage is the product of amps and volts. The 15 kilowatt generator is capable of providing 15,000 watts. Given a 240 volt system, the generator can supply approximately 62.5 amps, which aligns with the specifications mentioned. When connecting a generator to an automatic transfer switch, the transfer switch senses when utility power is lost and automatically switches the load from the utility to the generator. The transfer switch is typically a break before make switch, meaning it disconnects the utility power before connecting the generator power. This prevents backfeeding power into the utility grid, which can be dangerous and illegal. A qualified electrician will ensure that the transfer switch is properly installed and configured for the specific generator and electrical system. The electrician will also ensure that the grounding system is properly connected. Proper grounding is essential for safety and helps prevent electrical shocks. It provides a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. Grounding also helps reduce electrical noise and interference. The 200 amp panel is the main distribution point for electrical power in the building. It contains circuit breakers that protect individual circuits from overcurrents. The circuit breakers are sized according to the ampacity of the wires and the load they serve. For example, a 15 amp circuit breaker is typically used for lighting circuits, while a 20 amp circuit breaker is used for general purpose receptacle circuits. Larger loads, such as air conditioning units and electric heaters, may require 30 amp, 40 amp, or even larger circuit breakers. When using a generator to power a panel, it is important to ensure that the generator is properly sized for the total load. The load calculation should include all of the loads that may be connected to the panel at the same time. This includes lighting, appliances, and other electrical equipment. If the generator is not large enough to handle the total load, it can become overloaded, which can damage the generator or cause it to shut down. In addition to load management, it is also important to consider the starting current of certain loads. Some loads, such as motors and compressors, require a high starting current, which can be several times their running current. The generator must be able to provide this starting current without becoming overloaded. One way to address this is to use a soft start device, which gradually increases the voltage applied to the motor, reducing the starting current. Another approach is to use a larger generator that is capable of handling the starting current. Proper ventilation is essential for generators. Generators produce exhaust gases that contain carbon monoxide, which is a deadly gas. The generator should be located in a well-ventilated area, away from doors and windows. Never operate a generator indoors or in an enclosed space. Carbon monoxide detectors should be installed in the building to provide an early warning of carbon monoxide buildup. Regular maintenance is important for generators. The generator should be inspected regularly for any signs of damage or wear. The oil should be changed regularly, and the air filter should be cleaned or replaced as needed. The spark plugs should also be inspected and replaced if necessary. It is also important to check the battery and ensure that it is fully charged. A dead battery can prevent the generator from starting when needed. When refueling the generator, it is important to turn it off and allow it to cool down before adding fuel. Gasoline is highly flammable, and refueling a hot generator can be dangerous. Always use the correct type of fuel and follow the manufacturer's instructions. Store fuel in a safe location away from heat and ignition sources. It is also important to have a fire extinguisher nearby in case of a fire. Understanding the electrical characteristics of the generator and the loads it will be powering is critical for ensuring safe and reliable operation. The generator's voltage, frequency, and power factor must be compatible with the loads. The voltage should be within the allowable range for the equipment being powered. The frequency should be 60 Hz, which is the standard frequency in the United States. The power factor should be close to 1.0, which indicates that the voltage and current are in phase. A low power factor can cause the generator to operate inefficiently and can reduce its capacity. To address power factor issues, power factor correction capacitors can be installed. These capacitors improve the power factor by reducing the reactive power in the circuit. It is essential to consult with a qualified electrician to determine the appropriate size and type of capacitors. When using a generator, it is important to be aware of the potential for electrical noise and interference. Generators can produce electrical noise that can interfere with sensitive electronic equipment such as computers and communication devices. To reduce electrical noise, the generator should be properly grounded and shielded. Surge protectors can also be used to protect electronic equipment from voltage surges. Also, proper wiring practices are necessary. The wiring should be sized according to the ampacity of the circuit and should be installed in accordance with the National Electrical Code or NEC. The wiring should be properly supported and protected from physical damage. Conduit should be used to protect wiring that is exposed to the elements or that is subject to physical damage. Wiring connections should be made with approved connectors and should be properly tightened. Loose connections can cause overheating and can lead to electrical fires. The NEC provides detailed requirements for wiring installations, including conductor sizes, overcurrent protection, and grounding. Electrical codes like the NEC are updated periodically to reflect changes in technology and safety standards. It is important to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. The NEC is a comprehensive document that covers all aspects of electrical installations, from wiring to grounding to overcurrent protection. The NEC is developed by the National Fire Protection Association, or NFPA, which is a non-profit organization that develops codes and standards for fire and electrical safety. The NEC is widely adopted by states and municipalities throughout the United States. It is also used as a reference document in many other countries. In addition to the NEC, there may be local electrical codes that apply. These local codes may be more stringent than the NEC in some areas. It is important to check with the local authorities to determine the applicable electrical codes. The electrician should obtain all necessary permits before starting the work. Electrical permits are required for most electrical installations, including generator installations. The permit process helps to ensure that the work is performed safely and in accordance with the applicable codes. The permit also provides a record of the work that has been performed. When the work is complete, the electrician will schedule an inspection. The electrical inspector will review the work to ensure that it meets the code requirements. If the work passes inspection, the inspector will issue a certificate of compliance. This certificate is required for the electrical system to be energized. The cost of installing a generator on ATS can vary depending on the size of the generator, the complexity of the installation, and the local labor rates. It is important to obtain multiple quotes from qualified electricians before making a decision. The quote should include all costs, including materials, labor, and permits. When evaluating quotes, it is important to consider the electrician's experience and qualifications. The electrician should be licensed and insured. The electrician should also have experience installing generators and ATS systems. It is also a good idea to check references from previous customers. In addition to the initial cost of the generator and ATS, there are also ongoing operating costs to consider. These costs include fuel, maintenance, and repairs. The cost of fuel will depend on the type of fuel used and the amount of power consumed. The cost of maintenance will depend on the type of generator and the frequency of maintenance. The cost of repairs will depend on the type of repair and the availability of parts. When selecting a generator, it is important to consider the total cost of ownership, including both the initial cost and the ongoing operating costs. In summary, using a 62 amp 15 kilowatt generator with a 200 amp automatic transfer switch to power a 200 amp panel with a 150 amp load is feasible if the generator capacity meets the load requirements, the ATS is compatible, the panel capacity is sufficient, circuit breakers are appropriately sized, and load management is practiced. Also, safety must be the priority, proper installation is necessary, and generator overload must be avoided. Finally, fuel supply should be adequate and all electrical codes followed.